Is it long?
No. Just could be lots of writing. Okay. The problems that you have today, it seems like a bunch, but some of them are really short. Some of them take a minute to do, and some of them you just throw it in a formula and you're done. So there's only a few that take a while to do. So 9-5, we're going to use Pascal's triangle to expand binomials, and we're also going to use the combination to do so. So the first thing, you don't need to write this down. You need to look at it. Those are binomials. A binomial is two things, yes? Okay. So this binomial is x plus y to the 0 power. What's anything to the 0 power? 1. Okay. This is x plus y to the first power, which is just x plus y. But this is x plus y squared. So that means it's x plus y times what? X plus y. And you have to FOIL that out, right? Don't write this stuff down, guys. Don't. Okay. You just FOIL that out, right? Well, that's fine, but what about when I get to cubed?
Then
It's x plus y times x plus y times x plus y. So I have to do 2 of them, and then my answer I have to multiply by the third, right? Okay, well, how about x plus y to the 4th?
you did 2 of them.
I got to do it and do it and do it. Is that going to take a long time? Yes. So what I'm going to show you today are 2 methods, one that makes it a little quicker and one that makes it a lot quicker to do something like x plus y to the 5th. Okay? So that's what we're doing because we have to do those things once in a while. And I'm going to tell you that you may not remember the 5th row of the Pascal's triangle, but you should be able to make it to the 5th row, make the Pascal's triangle really, really quick. Okay, so what we have here is the binomial theorem. What you need to know is right here. Ooh, that was cute. What you need to know is right here.
What's under the C thing?
Okay, I'm gonna tell you. Okay, so the binomial theorem. You should have seen this before. If you took stats, you should have seen it, but it was used in a different way.
Yes.
Okay, so up here, all this says up here on the top is to expand a binomial. That's it. You don't need to write that. Okay? You do n choose r. You say n choose r equals n factorial over n minus r factorial times r factorial. So this would give you the coefficients of each term. So that would be what is in front right here, right? That would give you what's right there that they don't have the space for. That's only going to give you the coefficients. It's not going to give you the variables. Coefficients are numbers, right? Coefficient is the number in front of a variable.
Yeah.
Everyone? Mm-hmm. Okay, so we use this in probability. On Monday and Tuesday, you're going to be using that in probability. Or maybe it's just Monday. To find, not in probability. It will be find how many ways things can happen.
Yeah.
And then we're going to move into the probability using it as well. So another way we can write this, instead of n choose r, we can have n over r, but we still read it n choose r. Right here. And I've said this a million times. It's n choose r. This would give me the coefficients. Again, guys, when I had those binomials expanded, when these are expanded, right? 5's the coefficient, yes? 10, 10, 5. What's the coefficient here? 1 and 1. That formula would give me 1, 5, 10, 10, 5, 1. Got it? It's not going to give me the x's and y's. But look at the x's and y's. What do you notice about the x's as I go from left to right?
Be smaller.
The powers decrease, right?
Yeah, the
2,
Y's
1, and then a 0. And I wouldn't write it. And what happens to the y's?
They increase.
0, 1, 2. So then x is 3, 2, 1, 0. So it's 0, 1, 2, 3. Every time. Always going to happen that way. So the variables just come with the pattern. And the coefficients you have to calculate. So we have 8 choose 2. So what is my n? 8. What is my r? 2. So I plug it in the formula. So 8 factorial over 8 minus 2 factorial 2 factorial. So 8 minus 2 is what? 6 factorial. Remember when we reduced factorials, right? So 8 is 8 times 7 times 6 factorial, isn't it? Isn't it?
Yeah.
So 6 factorial and 6 factorial do what?
Cross out.
Reduce.
Or reduce, sorry.
And 2 is just 2 times 1, right?
So it'd be 8 times 7.
So 2 goes into 8 how many times?
4.
4. So it's just 4 times 7 is what? 28.
Over 8 minus 2.
No, it's 28. All this was 1.
8 minus
all that.
2 is 6 factorial.
Oh, yeah, I got it.
Yeah.
Can we try this next one?
Yep. You guys want to try the next one? You guys ready for me to start it?
Yep.
And if you finish that one, go to the next one. Oh, that's not right.
No,
Why
the
do you have
2's
a
in there.
7?
It's not. I added
Why do you have a 7?
because I added.
And you weren't supposed to do
What am I supposed to do? I add.
Subtract.
that?
No.
Multiply.
Multiply. Thank you.
Multiply.
Got the 7 from 10 minus 3.
I got the 7 from 3 and 4. I added them instead of
The
multiplying.
2, there's not a 2 in it.
How'd you get 101?
Okay, so you
I got
101.
I got 120 as well.
You put 2 on the bottom, but there's no
Can
2
you
in
actually
it.
walk
Yeah,
through
2
it
is
and
not
tell us
exist.
what
Okay.
you're doing?
10 factorial
Yeah.
over 10 minus 3, which is 7 factorial. 3 factorial. Yes?
Yeah.
So 10 is 10 times 9 times 8 times 7 factorial.
Yeah.
So 7 factorial and 7 factorial reduce.
Yeah.
And 3 is 3 times 2. 2 goes into 8 4 times. 3 goes into 9 3 times.
Yeah.
So 3 times 4 is 12 times 10 is 120.
So why did 24? Why couldn't you do
10,
like
10 and
on?
9 and 8 are not factorials. Hit for
After, okay, from this step to this step, the factorial went away.
What about
Yeah.
7, 6, 5,
Just get rid of
4,
Because
1?
this 10 times 9 times 7 factorial. And there was a 7 factorial here. And 7 factorial and 7 factorial reduced. If you need to write them all out, you still should have came out with the same answer. Yes,
My question was just how we reduced 8,
I took 2 into 8, which is 4.
and how did you get 2 though? Because
Because 3 is 3 times 2. Okay, let's do another one. Okay, I have 7, choose 0, yes? So it's 7 factorial over 7 minus 0. So that's what? 7. And 0 factorial. Now, 0 factorial is what?
0, 1.
1. Has to be 1. If it was 0, everything would be 0, right? So it's just 1, so it doesn't do anything.
Yeah.
And then I got 7 factorial over 7 factorial, so the whole thing is just
1.
1.
Because the 7 cross out.
Yeah, the 7's reduced.
So nothing over 0 is 1.
What?
So nothing over 0 factorial is 1.
It's not nothing.
No,
This reduces to 1, this is reduced to 1, and this is reduced to 1. So that's why I won't let you guys say cancel, because they don't cancel, they reduce to 1. So 1 times 1 is 1, and 1 divided by 1 is 1.
Can we do this one on our own?
Sure.
one.
Actually, it is. Because zero factorial is one. Oh, I forgot the thing.
Actually, problem.
Wait,
Okay.
I'm confused.
Why?
Because wouldn't the eights cancel out and that'd be a zero on top?
They reduce to 1.
I forgot my factorial sign, that's why.
This is ridiculous.
And
Why
either-
does zero
either way, zero
factorial reduce to 1?
Because if it wasn't 1, everything would be 0.
Zero factorial is one.
Just like anything to the 0 power is what? 1. Because it has to be, because if it was 0, would we ever get past 0 on anything? No. 0 factorial is 1. Anything to the 0 power is 1. They have to be that way. So this gets me the coefficients, and that's it. So what this is this right here would be x plus y to the 8th. Okay? And I want the second term. The second coefficient. Is what it is.
As your R.
My r would be the place.
So that one's the third.
So this is the third. This is the 0. The 0 is the very first one, guys. We start with 0. So it's 0, 1, 2. So this would actually be the third coefficient. So this is the third. This is the first. This is the 8th.
But so wouldn't it be technically like, since we start at 0, it would actually be like the 9th term?
Yeah, it would be the 9th actual term on the paper, yes. Okay, so what we have here is Pascal's triangle. Have you seen Pascal's triangle before?
No.
Okay,
Do we need this?
this is what you'll use to expand.
Do you want us to write this down?
Yes, it should not, but I don't want you to copy it, I want you to make it. So please listen, I don't want you just to copy this. Everyone understand me?
Yeah.
It is very easy to make. You start with 1, 1, and 1. Everyone write that on the paper. 1 in the middle, it's pyramid. Everyone see it's a pyramid, right? When you do pyramids, you put things in between numbers, right?
Yeah.
Okay, so we got 1, 1, and 1. Got it? Don't copy. Do not copy. I want you looking at your paper. Got it? 1 plus 1 is what? 2. Put 1s on the outside. You got your, that is the third row. Wait, that's 0. Second row. This is row, guess what?
0.
0. Okay? So now, look up here real quick, but don't copy. I'm going to take 1 plus 2 to get, and 1 plus 2 to get, and the outside is still going to be what? 1. So the next row, I'm going to get 1, and then 1 plus 2 is what? 3. And 1 plus 2 is what? 3. And put a 1 on the outside. So I got the next row. We're going to do one more together, and then I want you to not look up here and try the next one. So 1 plus 3 is what? 4. 3 plus 3 is what? 6. 1 plus 3 is 4, and put 1s on the end. Now try to do row 5 on your own.
How many rows are there?
There's infinitely many rows.
So we could just.
You only need how many you need. If I'm on a monomial to the 10th degree, I need the 10th row. Now, I'm not going to give this to you, but is it really easy to make? Yeah. So did you get 1, 5, 10, 10, 5, 1?
Yes.
The next one's going to be what? 1, 6, 15, 20, 15, 6. Okay. What do you notice? This is the degree of the monomial, isn't it? Yeah? That's the degree of the monomial. If the degree is even, there's how many terms in it?
3.
Or an odd number. The degree is even, there's an odd number of terms in the row. If it's odd, then there's a what? Even. Even rows have a definite middle, don't they? Odd repeat itself. So you get 10 and 10. So when you get to the middle, you just go down, don't you? So I had squared gives me 3 terms, cubed gives me 4. 18 would give me how many terms? 19, one more term. Okay, so that's why evens have a definite middle, because they're always going to have an odd number of terms. So we calculated A8, yes?
Yeah.
And we got it to be what? What?
1.
Yes? Well, 8 would be the 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, that's always 1 out there, isn't it?
Yes.
We also calculated, what, 8, 3?
Yes.
Right? So let's do the row and make sure we're right.
Wait,
So 1.
I did.
What's here?
8,
8,
28,
28,
56, 70.
and then it's going to drop, right? Didn't we do 8, 3? 8, 2?
But it was 28.
Okay, so 8, 2, this is 0, 1, 2. Did we get the same number? Yes. So, let me finish this out, just in case anybody... we got the same number. Using the formula, if I need one coefficient is great, correct? But if I have to multiply out a binomial to the 8th degree, is using the formula going to be very time efficient? No, because I got to do the formula 9 times. Well, first of all, I should know anything 0 and anything itself should be what? 1. And this is a choose, guys. If I have 8 things, how many ways are there to choose 8 things?
9.
If I give you 8 pieces of candy and say, now you can choose 8,
Oh, yeah.
how many ways can you do that? 1. If I put 8 pieces of candy out in front of you and say, you can't have any, how many ways is there to do that?
0.
1. There's only one way not to get anything. So does that work for every number? 28 choose 0 is what? 28 choose 28 is what? 1. So those ends are always going to be 1, aren't they? Okay. So that's, after you've used this a bunch, I usually can get to row 5 without having to do anything else. Just I know 5 is 1, 5, 10, 10, 5, 1. And then I have to go and make it. But if I had to make this up to the 18th row, would it take me that long? No. A lot less time than doing the formula 19 times. Correct? Yeah. Okay. So, you guys have the 8th row down on your paper? Because we're going to need it.
Actually,
Which one's the 8th row?
Well, that one. Did you have like all that?
I got down to the 35, 35, 21 row.
Oh, yeah, you're probably fine. Actually, you're fine there. You're fine. I don't think we need the 8th row. Oops. Okay. This right here, we are not going to do all of them. I just verify them. Does that make sense? We're not going to do them all. I wanted to show you, and we did already. It says, use the 8th row of Pascal's triangle to find the binomial coefficients. Well, we did this, yes? It was 1, what? 8, 28,
56.
56,
7.
and then 56, 28, 8, 1. Is it always going to be a mirror image?
Yeah.
Yes, always. So it's just showing you that you can use the formula or you can use Pascal's triangle. If I gave you the choice, which one would you probably use? Pascal's triangle. We'll use this, the choose, when we're doing numbers of ways to find things or when we're doing probability, but it is not what I typically use to expand a binomial unless they tell me I have to, and then I am saying nasty things about them the entire time. I will not make you. Now, what happens is you do not need to write this down. Please don't. We'll be here forever. Remember I told you how the x variable goes down in degree and the y variable goes up. Well, it's the first variable goes up, down, and the second goes up. Could I change those around? Yes. It doesn't matter what's first and it doesn't matter what's second. The first goes down and the second goes up. Every time. Do you see that pattern happening? Look at the 3rd row. X is 3, 2, 1, and there's really an x to the 0 here, isn't there? Because anything to the 0 is what? 1. And here we have y to the 0, the first, the second, the third. Okay, the seventh row, 7, 6, 5, 4, 3, 2, 1, 0. What's y doing? 0, 1, 2, 3, 4, 5, 6, 7. What do you notice that each of these pairs add up to be? 7. Every time. What should all of my pairs of exponents add up to be if I'm going to the fifth? 5. Do they?
Yeah.
It is a quick check. It is a check you should take a second to do. So now let's combine everything. How's that sound? Quit going backwards. Okay, it says write the expansion of x plus 1 cubed. Okay, so what row do we need?
3.
3. So that should be 1, 3, 5, 3, 1, correct?
Yeah.
Am I right?
Check.
I don't hear confidence there. I hear,
No, 1, 3, 3,
Oh, I made it an even, didn't I? Okay, 1, 3, 3, 1. That's why I said check. I don't have it in front of me. I know my coefficients are going to be what? 1, 3, 3, 1. What are all my exponents going to add up to be?
1.
3. Okay, so I have x plus 1 cubed. So my coefficient is going to be what? 1, x to the third, y to the 0. Plus, always put plus. Let your math decide whether it's positive or negative, because you will get positive and negative stuff happen.
So now 3 will be your next.
Okay, so
winning
3
coefficient.
is my next coefficient. X to the y to the first. Plus 3 x to the y to the second. Plus 1 x to the 0 y to the
Third.
Where do I get that?
Okay, and then obviously I'd write it x cubed plus 3xy plus 3, how about squared? Xy squared plus y cubed, yes?
You don't want, if we have this.
I don't want that in your final answer. Now today I expect to see some zeros going around so you can see that happen every term, but your final answer should be simplified nice and pretty. Okay? But show your work. Don't try to do it in your head. You're not good enough to get it and do it in your head and get it right every time. You're not. Okay? Could I have done this in my head?
Yeah.
Yeah. But the next one you probably couldn't. Okay. So expand 2x minus 3 to the fourth.
1, 4, 6, 1.
Okay, so I want the fourth row. Yes? And it is 1, 4,
6.
6, 4, 1. See, I put my 6 in my 3 row, didn't I? But I didn't stop and think that 3 is odd, so it should be an even number, did I? So that's what I was doing. So I have that. Now my first term is what? 2x. Before it was 1x, so it didn't matter. But now it's what?
2x.
2x.
So do you multiply
And-
by
And my second term is
negative?
-3. Okay? So first term is 2x and my second term is -3. So the degree on the first term is going to go down. The degree on the second term is going to go up. Okay, so I have 2x minus 3 to the 4th. Yes? Okay, my coefficient is what? 1. Parenthesis, 2x to the 4th. Parenthesis, -3 to the 0. Plus, I want you to see the pattern. That's why I'm putting the zeros there. Got it? Okay, what's my next coefficient? 4. First term,
2x
to the
to the third.
third. Second term,
-3.
to the first. Coefficient,
6
first term,
to the second. -3 to the second.
okay, are my exponents adding to 4 every time?
Yeah.
Okay, plus
Why aren't you putting a Y with
Yeah, that's what I was looking at.
There's no Y.
There
There
wasn't
was
a
no
Y.
Y.
If
the
there
last
was
one
a
either.
Y there, then we would.
There wasn't a Y for the last one either.
It was just X plus 1 for the last one.
There was. We will
I
go
have
back,
no
we
clue
will
where
go
you're
back and
getting
fix
the
it.
Y from.
We will go back and fix it. I apologize.
But if the way that we did it, there should have been a Y in the equation for us to do that.
Yeah, it would have been Y and not 1.
Okay,
So if you want to change the equation to Y,
X plus Y.
just change X plus Y, and it will be fine. Then we can go back to do X plus 1 in a second. I apologize. My brain stuck a Y there. Okay, next one is 4 times
2x.
2X to the first.
and negative 3 to the third plus
1,
1,
2X to 0,
2x to 0,
negative 3.
negative 3 to the fourth. Before I do anything else, I look. Do I have 1, 4, 6, 4, 1?
No.
Do I have 2x to the fourth, third, second, 1, 0?
No.
Do I have 3x to the 0, 1, 2, 3, 4? Now you think I'm stupid for asking you that, but sometimes we go from 2 to 5 when they're big, okay? Stop a second and save yourself some time. Now we just go do the math. Well, I have negative 3 to the 0 is what? 1. And all these are times each other, yes? Okay, well, I have 2x to the 4th. So that means 2 to the 4th, which is what? 16x to the 4th, correct? You have to take that 4 to both. Now I come here, and I'm going to have 4 times 2 cubed is 8, x cubed, right? And then negative 3 to the first is negative 3. I should use parentheses and not dots. So I need to take, well, let's see, do you guys know 12 times 8?
No.
96, is that right?
Maybe that was one.
Yeah, it'd be negative 96, but 12 times 8 is at 96. Okay, and it is negative 96x,
What'd you get 96 from?
12 times 8.
Why are
3
you
times
taking
4 is 12. Times 8.
Why are you taking those two?
Because this is all multiplied together. And multiplication I can do in any order, and my brain can do 12 times 8 easier than it can do 32 times 3. 32 times 3 is not too bad either, is it? But I have to multiply them all together. It doesn't matter which order. No. Okay, now I'm going to go to the next one. So I'm going to have 6 times
4.
x to the 4th times,
That's
It's
squared.
X squared, right?
oh, squared, yes. I wrote 4 twice. I'm just wanting to
Plus 9.
plus 9. Because 2 negatives make a
So
Positive.
54.
216X.
54 times 4.
50 times 4 is 216. Is that right? So plus 216 x squared. Next one, is it going to be positive or negative?
Negative.
Negative. Where am I getting the negative from?
Your exponents
Negative.
are negative.
The exponents are odd. Yeah, and so we're going to have a negative on those, right? Okay, so then I have 4 times
2.
2x times
Negative 27.
negative 27. So it's going to be negative, and 6 times 27 is for 160.
You mean
One.
8?
You mean 8?
Oh, I added. 8, yes. Okay, 8 is
Why
what?
do you do
6,
54 times
5, 6, 5,
It's still
216. Still 216. So 216 x.
Yeah.
Now, that is not always going to happen, that they're the same. Got it? And then we're going to do plus next one, right? Well, this is 1 times 1, and 9 times 9 is 81. See how it didn't mirror. The only thing we had was that 216 happened to be the same. It does that. Don't think it mirrors. None of that happens there. So could I have done that in my head? Not till I've done it a while, right? But if I write it out, does the math just kind of fall into place? Was that still quicker than taking 2x minus 3 times 2x minus 3 and then taking the result times each other again?
Yeah.
Probably. I think that's our last example. Oh no, we got another one. Oops. Don't do that. Okay. So I have x minus 2y to the fourth. So it's still 1, 4, 6. It was working fine earlier. 1, 4, 4, 6, 1, 1. Okay, and the first term is what? X, and the second term is negative 2y. So I have x minus 2y to the fourth. You guys want to try this one on your own? No? Yes. If you want to work on your own, work on your own. Do you want me just to talk while I work? Would that be okay? Yeah. Okay. So x to the fourth, so 1 times x to the fourth, negative 2y to 0, plus 4x cubed, negative 2y to the first, plus 6x squared, negative 2y squared. Make sure your square goes outside the parentheses when there's two things, because that square goes to both. Plus 4x to the first, negative 2y to the third, plus 1x to the 0, negative 2y to the fourth. 1, 4, 6, 4, 1. 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. Okay, you good so far?
Can you give me something?
And again, I stopped, I took a step back. I can't see my whole paper like you guys can right in front of you. It took me like less than 30 seconds to check that, didn't it? Okay, so then I'm going to have 1. So I get x to the fourth. And this is going to be negative 2. So negative 8x cubed y. This is going to be 4. So plus 24 x squared y squared. Negative 8. So negative 32 x y cubed. So plus 16 y to the fourth. I got 24 from negative 2 squared is 4 times 6 is 24. Now, could I have a 3 with this x also?
Yeah.
Yes, and then I would have to do, when I get coefficients in front of my variables inside the binomial, does that make it harder to do? Well, maybe not harder, but bigger numbers.
Yes.
That's how we get our bigger numbers. Okay.
And you said every last, with the negative 2y, put the power outside the parentheses.
Yes.
It goes to both of them.
Yes, because if I would put the 4, what if I would write negative 2y to the fourth? What's to the fourth?
The negative 2y.
No, it's only it's only to the y. So when there's more than one thing, your exponent has to be outside. Because if I would put that 4 in the quantity, it would only be what the 4 is on, which would be
It doesn't go to the x in front of it?
what?
It doesn't go to the x in front of it?
No, because negative 2y is the whole thing. Or are you talking about just the x's?
Yeah, I mean, I thought that you meant that, on the last one, you have your 4 outside. I thought you meant that goes to negative 2y and x.
Oh, no. It goes to everything in just that quantity. Sorry. And the x was just x to the first, so or 1x, right? So it didn't matter. Okay, if you want to do it always on the outside so you don't forget, then always put it on the outside so you don't forget. Questions, guys? Do we need to go back and do that x plus 1 again?
I mean, if you just change it to y.
Yeah, if you just change it to y, to y at the beginning, you're good. I think this is the last one. I didn't think we had too many.
And if it were to be 1, we just wouldn't have our y.
No, we don't need to.
Yes, if it was 1, all of those y's would have been 1, and 1 cubed is 1. Do you need another one? No. Okay, what's different about this one? It has an x squared.
So we should.
So what do
I
I,
think we should.
So that would be x
what's my row?
to the
It's the third row.
So it's
six.
1,
3,
3,
1.
3, 3, 1. Okay? So x squared plus 4. So it's going to be 1x squared to the what?
To the
Third. Times 4 to the 0. Plus 3x squared to the second. Times 4 to the first. Plus 3x squared to the first. 4 to the plus 1x squared to the and 4 to the third. Okay, so x squared to the third is x to the
Seven.
sixth.
Oh,
Did you get 7?
I thought that looked like a 4. I didn't get a square.
I can't fix it because it's just going to look worse. Okay, I multiply exponents. That's why I put this one in here. You got to remember to multiply exponents, right? And then 1, and then I'm going to have 4 times 3 is 12. X to the fourth. And then I'm going to have 16 times 3, right? So 48. X to the second. And 4 to the third is 64. Okay, what do you notice about your
Isn't
exponents?
there an x there still?
No, because it's x squared to the 0. What's anything to the 0?
Oh, they are going up by 2 every time.
They're going up, going down.
That's arithmetic or down, but like I'm
Okay, so it is still going down, yes.
b is negative
Yes.
2.
And we had cubed, yes. But why is it 6?
Because it's x squared.
Because it's x squared. Okay. So that x squared is going to change. It's going to change what it. Now, if I go here, do these still add up to 3 every time?
Yes.
Yes. So that's why I check it at this step, not at this step. Because the final step isn't always going to add up to 3, is it? No. So, I keep thinking this is the last example and then another one pops up. Want to see what we find? Oh, it's not lit up. So it's not.
You can leave it there though.
At the last one? This one? Okay, so that's what we're doing today. If it tells you use the formula, use the formula. If it tells you use Pascal's triangle, use Pascal's triangle. Now, I would hope